Okay, so we saw that in this diagram we don't have a real figure, so therefore we can't just use length times width, but when it's a triangle we can do anything. So we had to cut it into two parts. We spoke about this. The good choice would be to draw a line AC. Do you all agree? Did you do that? Okay, so in ABC, in triangle ABC, and this is something that I would also suggest you do just to clarify your own work in your own book, is to before you start, when you have got two triangles, to just say in this triangle. Then when you are going to put everything together, you know what you did where. Okay, so I said in triangle ABC, so it's this left one. I calculated the area and found it to be 649,519 units squared. That was easy, no problems. Then once again in triangle ABC, so I'm still staying in this one. I'm not working in the other one yet because I don't have enough information in the other one. In this triangle again, I'm going to find the length of the small letter B, so it's the side, but B is also the side AC, and it's also called side D in the other triangle. Do you all agree? All three of them are the same. So B squared equal to A squared plus C squared minus 2AC cos B. Do the substitution, it's the easy one, where everything is already on one side. You get an answer, and just remember to take the square root, and it was a nice whole number, AC or B or D is equal to 70 units. Now once you have this 70, it means you have this length, 70 here. Where now in triangle ACD, you've got three known sides. And when you've got three known sides, you can use the cosine rule. Now, our angles will probably differ. I chose to calculate the size of angle D. You could calculate the size of A or C. You would get to the right answer if you did everything right, with only a change or a difference in the decimals. That's the only we can expect there. I want to show you the manipulation here again. So the 70 squares on this side minus 65 squared minus 80 squared. Put it in a fraction over negative 2 bracket 65, close the bracket 80. And then what's left is cos D, so I still need to take the cos over, and then it becomes cos negative 1. And that gives you the answer of angle D, and therefore D is equal to 56.6 degrees. Once you have that angle, you can substitute. This is now my fourth sum for the area of triangle ACD, and then you find the area to be 2,170 units squared. So whether it doesn't matter which angle you chose there, A, C or D, your area should be around about the same value there if you did everything correct. Is there someone that chose a different angle and also got the same area? Are you all right with that? Okay. And now the small sum, the fifth sum, is just the two areas that you calculated, to add them. Now, I told you yesterday as well, because you're doing so many things, I would suggest, I just want to zoom out so you can see the big sum here. I'm sure yours look like this as well, but when I calculated the first area, which is a part of the answer, I know I highlighted it to remember it, because I still need to use it when I get the other triangles area to add them. Do you understand? Who got it right? Well done. Good job. Okay. You can, when you are doing or marking your work, you must do your homework. So I expect you to just write the correct answer, and then I want you to try it again in the afternoons, okay? Doesn't mean you're getting it right if you're copying from the board. So if you get it wrong, write down the correct answers that you're going to need, and then you go and do it at home. Don't just copy the whole thing, okay? Right, because also we are wasting time. So we get to the next one. Before I do the sum, the correct answer of number 3 was total answer 19,4 square kilometers. Who got it right? 19,4. Not a single one of you. Sure. Who got anything close to 19,4? Okay, you are going to kick yourself when you see how easy this is. Okay, are we ready to go? When I look at the 3 triangles, I see that I have quite a lot of information in triangle BCD, but very little information in ABC. Do you agree with me? We want to eventually calculate the area of the farm. So they already did that cut in there, so I know I'm using those 2 triangles. In the right-hand triangle, so in triangle BCD, I can calculate the area immediately because I have 2 sides and an included angle. So it's going to be A equal to a half. Now remember, you can also split it if it's easier for you. So this is side C, this is side B, and angle D. So it's BC sin D. So it's a half times 3 times 6,2 sin 72 degrees. And then you get an answer of, the answer there, 8,844 square kilometers. Do you agree with that? Yes. No problem there. It is second part, the second triangle, where we came across some difficulty. Now, if I consider a triangle ABC, I only have one known side. So I'm going to start with the easiest part, and that's finding another side in triangle ABC, because there's a common side BC. Okay? BC is also part of the right-hand triangle, and I have information in the right-hand triangle to find it. Do you agree with that plan? Okay. So I'm trying to find the length of BC. I'm working in triangle BCD. So this one. What I have is 2 sides and an included angle. That means I can use the cosine rule. And it just so happens, because I've got angle D, I can find the small letter side D, which is BC. Right, so I'm saying D squared is equal to B squared plus C squared minus 2BC cos D. D squared is equal to 3 squared plus 6,2 squared minus 2 times 3 times 6,2 cos 72 degrees. Then D squared is going to be equal to 35,9445 what. Take the square root, and then D, am I still on the board, is equal to 5,99999 which is 6. Do you all understand that? Yes. Do you know what line I just calculated? Which side? Okay. Now back in triangle ABC, I have two known sides. I know BC is 6, this one is 5,4, but I need something else. Now there's no way for me to find the length of AB. Do you agree with that? If there is a way for me to find angle B, then I know I can find angle A with the interior angles of a quad, but I can't find B1 and 2. I can only find B2. Do you agree with that? I have angle C as 120, but I don't know what C1 and C2 is. Let's go back to B. I said we can't find the whole B, but we would be able to find B2. Do you agree with me? Is that the same for C? Would we be able to find C2? C2, that's part of BCD. Can I find the value of C2? Let's say I find C2 to be 50. What does that mean? If C2 is 50, and it's something I can calculate, that means I also have C1. And C1 is part of the triangle that I want to work in. And then I have enough information. Do you see how easy it is? Okay. Because we have the whole angle, we can find the part that we're not really interested in. But once we have C2, that's the step we need to get to C1. Everyone, do you all understand? Okay. So I'm still in triangle BCD. I want to calculate the size of angle C2. Okay, in order for me to find C2, I can use the sine rule, because C2 and its side I have, and I have D and small letter d. Do you agree with that? I'm not even going to check for cosine. I told you guys I don't like cosine when I have to find the angle. So I'm going to say sin C over C is equal to sin D over D. Are you all with me? So to get C alone, I'm going to say 6,2 sin 72 degrees divided by 6, and I have shift sin on this side. You type that in your calculator, and then you find C to be equal to 79. This is now C2. So now I can go into triangle ABC, where C1 is going to be equal to 120 degrees minus 79. understand what happened here? Beloof? Right. How much will it count? It won't be asked in one big question like this because it adds and adds and adds. But I would say 1, 2. That will probably be a full question with the sub-questions, 13 to 15 marks. And then that will be the only question on area, sine and cosine rule. Okay, are you done? That's the standard type of questions that we're going to get in the exams. We are going to, you remember I gave you that 3 question papers a while ago that has all of the trigonometry on it. We're going to do a couple of sums in there so you can see it. But before we get to that, I want to get to the level 4 sum that I have told you about. And I need you to understand that this question is not necessarily always in a question paper. You will see if you go and search for one to practice, you will look quite a bit at quite a few papers before you find one. Okay, so I don't want you, when you're studying for an exam, to just focus on this level 4 question because it's the hard one. And then you forget about the first ones. Because in a question that counts 15 marks, this level 4 can only count like 4 marks. But then you've concentrated so much on the difficult one that you didn't study and practice the plain ones enough. And then you are going to struggle. Okay, then you're going to lose lots of marks. So I'm going to do an example for you here. This is just, it's still the same. It doesn't have a new heading. You can just write level 4 or whatever you want to. Don't draw the second triangle that I'm going to draw now. I just want to show you a much easier example. Okay, can we look at it? Now, the shift that you're going to have to make in your minds is normally when we have an x, we consider that as our unknown. Do you agree with me? Then we would have an x and we would have 10 or 32 or whatever, and then the x would be the unknown. But we get to sums where we consider having information about the angle as that angle being known. In other words, angle B is known because it's beta. Angle C is known because it's theta. Angle D is not known because I have no information on it. DC is known because it's x. BD is not known and BC is not known. Have you ever heard the words in terms of x? No? Have you heard it? That means you are taking an unknown and giving its value in terms of an acceptable variable, which is x. So for instance, if you are building a bridge, you want to create a formula to build the bridge. We are saying, right, you can have x's in there, you can have y's, you can have z's. Okay, but everything must be in terms of x. X might be the length of the bridge. So you can use this expression or this equation, but this is the whole sum. You're going to have to put in for your specific bridge, what is the length of the bridge. Then you're just going to put in x in the whole sum and it's going to work out. Does that make sense? Okay, so it's a equation with unknowns, but the unknowns repeat. Okay. Maybe y will be the width of the bridge. So you're just going to put that one in. And z will be the number of kilograms the bridge must be able to handle at one or at the same time. So it's three unknowns. You can imagine it's not just going to be x plus y plus z, no? It will be a whole complex equation. And then when you want to build that bridge, you're going to say, okay, I want this bridge to be 10 meters long, 2 meters wide, and it must take a ton at once. You can put it in the formula, it works it out. So that's what we're doing. Looking at this one, this is a grade 8 one. Do you see it's an isosceles triangle? According to what we have here, only A is known because I have information on it, it's x. But do you agree that we can give the value of C in terms of x? What is it? X, because it's isosceles. And do you agree I can also give B in terms of x? What will that be? 180 degrees minus 2x, which in its simplest form will be 90 minus x. So you've just made all of the angles known without knowing what x is. But all you need to do is know the value of x. If it's 10, if this one is 10, this one's going to be 10, this one's going to be 180 minus 10. Let's not use that one. 180 minus 20, it's going to be 160. Okay. If you know x is 20, this one is 20, it's going to be 180 minus 40. It's going to be 140. So it is known, although it's not completely known. So that's what we're going to have to shift our minds to when we do these sums. And now we can find angles. I just saw that you guys know pretty well what you're doing when we have angles. But we're also going to have to be able to find sides with the sine and the cosine rule. And that's why we needed the manipulation. Okay. Firstly, I want D, angle D, in terms of beta and theta. B in terms of beta and theta. Who wants to try? It's easy. Bokang? 180. Okay, now that's perfectly right. He says 180 minus beta and minus theta. But I want to ask you one thing. You guys remember that in trigonometry, we have, when we're getting our reference angles, we will have 180 minus whatever, or 90 degrees plus or minus whatever. Do you agree with that? So we always want to try to keep it in a format of 180 minus whatever. So the whatever, let's just keep it in brackets. Do you understand? Because when you've got a sin or a cos or a tan in front of this 180 minus, that 180 minus can disappear. Do you agree with me? Because the 180 only puts it in a, yeah, that was a bit loud. I didn't, just woke up or something. That 180 minus just puts it in the second quadrant. So if we have sin 180 minus, it's just gone. If we have cos 180 minus, it's negative cos of the two angles. If it's tan 180 minus, it's negative tan of the two angles. So that's why we want to keep it in this format. When it's 180 minus theta minus beta, then it doesn't work. You can't just throw it away. Do you understand, all of you? Okay, great. That was the first step. That is the size of D in terms of theta and beta. Now the next step, or the next question, they want BC. They want you to show that BC is equal to x sin beta plus theta divided by sin beta. That looks a bit scary, no? But doesn't that look like a rule? One of the rules that we just did. Which one does it look like, Mocho? The sine rule, no? Do you agree with me? Because sine rule has the sin of the one angle over the side, the opposite side, equal to the sin of the angle over the its opposite side. It kind of looks like that. Okay. Do you see that D is also that thing that we just spoke about? Somewhere in there as well. So we're going to use it. Okay, but let's just ignore the answer first. They basically want BC using the sine and the cosine rule. How do I know I'm using the sine and the cosine rule? Because it's a triangle and it doesn't have a 90-degree angle in it. So then you know sine, cosine. Okay. The one thing I want to look at here is to help me, to lead me to use the right rule. But when you look at the triangle here, I've got two angles and a side. Which rule can I use with two angles and a side? That is the sine rule. Okay. So, let's pretend I had values here. What I would do is I would say D over sin D is equal to, then I need to look for a full ratio, no? So it's B and B, equal to B over sin B. Now normally what I would do is I would now substitute the values. Okay, but D, we just wrote it there. Do you see the value of D? So it's going to be 180 minus theta plus beta, or beta plus theta, it's the same thing. This I got from the first question. Equal to, B is x, and it's sin beta for angle B. Is there anything that I just did that you don't know where it's coming from? Are you all fine? Do you see what I always tell you? Everything stays the same. I haven't done a single thing different than what we've been doing using the sine and the cosine rule. The only difference is that I don't have a 30 degrees or a 20 degrees or a 10 centimeters. I have it in terms of variables. Don't try to do something different when they're giving you something different. I'm going to take this thing over to the other side because that is what I would have done if this was a normal sum. But remember, I also said I will write it now here. 180 minus puts me in the second quadrant. And what is sin in the second quadrant? Positive, so it can just go away without any effort. Theta plus beta, and you can write beta plus theta, it makes no difference. Over sin beta. Now, check what they gave you. X sin beta plus theta over sin beta. I didn't do one thing different. It was all the same. Is it hard? Just stick to the rules. Are you done writing? Okay, I want you to look here with me. This one, if you want to open your textbook, it is on page 184 if you prefer watching there. They're telling you that in this, they've given you this diagram. This is theta, and then they want you to give the coordinates of P, that one, in terms of theta. In terms of theta. Okay? In terms of theta. Let me just get my pencil. Where is it now? They've given you this coordinate as x and y. Do you agree that makes this one x and it makes this one y? Okay? This length is 1. Right. Who can help me? Think about it. You can write it. You can draw it on your book there as well. Let's try to make a plan to get it in terms of theta. I will give you a hint. You're going to use a trig function there. Okay, let me help you with this. They don't want that P, the x value, to be x. Okay, so the side they are referring to, when they say in terms of theta, the only variable can be theta. But there can be a sin, there can be a 1, there can be a anything. There must just not be a x or a y. So this side x, if you look at theta, what is the x side to theta? Adjacent. Is the opposite side, is it known or is it a variable? Remember, they are saying in terms of theta, so the only thing I consider known is theta. So that y is not known. Is that side that is 1, is it known? Yes, because it's 1. So the sides I can use is this adjacent one and the hypotenuse. Which function goes with adjacent and hypotenuse? Cos. Now, you are not allowed to do what I'm doing now in the textbook. Okay? It's cos theta equal to adjacent is x over 1. I want to finish this. So how do I get x alone? X is equal to cos theta. Can you do the same for y? Y is now the opposite. And the side I have is hypotenuse. Which function is opposite and hypotenuse? So the sin of theta is the opposite y over 1, which is just y. So now that x in terms of theta is cos theta. And that y in terms of theta is sin theta. So now if you get theta, you've got all the information. So you're not doing anything. You're just getting it in terms of theta. Okay, so what I want you to do for me for tomorrow, and I want you to check in your textbook that it has already been changed. They say P, Q, R, and then R is alpha, PQ is equal to PR, but in your textbook, it used to say, or they used to put the lines there. Just make sure it's the same as in the information. PQ is equal to PR. Do you understand? So what you have here, what's given, or what's a known value, is alpha and x. Do you already see another angle that's alpha? Can you give the third angle in terms of alpha? Okay. Can you see which rule, well, they're in any case telling you, but can you see which rule they're using without them telling you? The sine rule to find QR, just like the example that I did for you. Okay, you're going to do that number 3 for me. And then, for a challenge, you're going to do number 4 for me as well. Just look, it's the same triangle. It must also be PQ equal to PR. But now they want you to use the cosine rule to prove that QR squared is equal to 2x squared bracket 1 plus cos 2 alpha. You've got alpha, you can find another angle, you can find the third angle, you've got this side is x, you've actually got the other side as well. So all you need is QR in terms of x and alpha. Are you going to try the 2 for me? Okay.